Welcome, everyone. I'm excited to dive into the world of retrieval augmented generation with you today and explore how it relates to our work as technical communicators. But before we dive in, let me introduce myself. I'm Manny Silva, the head of docs at Skyflow, where my team owns documentation, UX writing, error messages, and so much more. I'm also known for codifying the docs as tests approach to documentation content validation, for creating Doc Detective, a tool that automates documentation testing, and for practical LLM research in the documentation space. I'm a tinkerer at heart, and I'm passionate about the intersection of technology and documentation. Here's what we'll cover today. We'll start with some background on LLMs and their challenges, then dive into RAG, Retrieval Augmented Generation, exploring both vector-based and graph-based approaches. We'll discuss how these approaches affect our documentation practices and look at a real-world implementation. Finally, we'll consider some future trends and then wrap up with Q&A. Let's start by framing the problem we're addressing. LLMs have revolutionized AI, but they face significant challenges when it comes to up-to-date and domain-specific knowledge. As technical communicators, we are uniquely positioned to help solve this problem, and RAG is a key technology in this effort. To understand RAG, we need to understand how we got here. LLMs have evolved from simple rule-based systems into complex neural networks. Key milestones include BERT, which introduced bidirectional training, and the GPT series, which pushed the boundaries of what's possible with language models at all. Today's models, like GPT-4o, Claude 3, and Palm 2, are incredibly powerful, but they still have limitations. LLMs are trained on vast amounts of text data, including documentation, not limited to it though. But this approach has several limitations. The training data becomes outdated, leading to a knowledge cutoff where the model doesn't know about recent events or developments. Additionally, when asked about topics outside of their training data, LLMs produce hallucinations, plausible sounding but incorrect information. Hallucinations are a critical, sometimes disastrous, issue with LLMs. They happen when the model generates information that sounds correct but is actually false. This can happen because of biases in the training data, overfitting, or as simply the model's attempt to provide an answer when it doesn't have enough information. Hallucinations can seriously undermine user trust and the reliability of AI systems. This diagram illustrates a few limitations of LLMs operating on their own. The pre-trained knowledge is limited by the training data, leading to out-of-date information, missing domain knowledge, and the potential for hallucinations. RAG, or Retrieval Augmented Generation, is a technique that aims to solve these problems by dynamically providing LLMs with relevant information at runtime. It combines the power of information retrieval with the language generation capabilities of LLMs and allows us to keep the model's knowledge current and to reduce hallucinations. Here's how RAG typically works. When a user submits a query, the system first retrieves relevant information from a knowledge base. This information is then added to the prompt and sent to the LLM. Finally, the LLM generates a response based on both its pre-trained knowledge and the additional context provided. RAG offers several key benefits. It allows us to provide the LLM with the most current information, to integrate domain-specific knowledge that might not be in the original training data, to reduce hallucinations by grounding the model's responses in the retrieved facts, and to improve explainability of an LLM's response by linking responses to the sources that it gathered information from. But there are a few different kinds of RAGs, and the first one that we're going to cover is vector-based RAG. Vector-based RAG is the most common implementation. It's what most people mean when they just say RAG. It works by converting both documents and queries into numerical representations called vector embeddings. These embeddings capture semantic meaning, which allow us to find relevant information through similarity searches within the vector space. In short, it allows us to find similar topics, similar themes, even if the exact same words aren't used. A vector-based RAG system consists of a few key components. The document processing pipeline prepares and encodes documents. The vector database stores these encodings efficiently. The retrieval mechanism finds relevant documents based on query similarity. And finally, the LLM integration combines retrieved information with a user query to generate a response. It looks something like this. This illustration of the flow of information in a vector RAG system starts from the left with the user query. The user query is processed by the retrieval system, which searches the vector database for relevant documents. These are then provided to the LLM along with the query so that the LLM can generate its response. Vector-based RAG has a few notable advantages. The similarity search is very efficient, allowing for quick retrieval. It's also language agnostic, meaning the same system can work across multiple written languages. And finally, it scales well to large document collections, making it suitable for enterprise applications. But that doesn't mean that everything is sunshine and roses. Vector-based RAG also has severe limitations. It doesn't explicitly understand relationships between concepts, which can lead to missing important contextual nuances. It can also struggle with long-form content, as embeddings have a fixed size and may not capture all of the relevant information. Additionally, vector-based RAG systems only know what they know. They don't know what they don't know. There's no known unknowns. So they are only aware of the things that exist in their system. If something is not included in the RAG information, then it still exists outside the LLM and RAG system's knowledge. Now, the quality of a RAG system heavily depends on how well you process your docs. This processing involves several steps, including cleaning the raw text, pre-processing to normalize the content, chunking the text into appropriate segments, and generating these high-quality embeddings. The first step is document processing or cleaning and pre-processing. This involves removing parts of the document that aren't relevant to the LLM or the RAG system, like navigation menus and footers. Note that document metadata, such as which product and product version the document belongs to, can be important, so we do need to preserve that. We also need to handle special characters and formatting that might interfere with processing. And then finally, we normalize the text to ensure consistency. That means lowercasing things as appropriate, trimming additional white space, those sort of manipulations. Chunking is where we split our documents into smaller pieces that can be embedded and retrieved effectively. There are different strategies for this, from simple fixed-sized chunks to more complex semantic chunking that tries to preserve logical units of information, such as keeping code blocks with the content discussing the code. Now, why do we have to chunk? It's important to chunk content because even with the large context models that we have available today, the more context you put into a single LLM inference call, the more it's going to cost you. You want to have your content chunked in such a way that you can provide the minimum necessary amount of content to give you the response that you're looking for. Now, part of what's important here, in addition to deciding the size of your chunks and making sure you maintain enough information within each chunk, is you have to seed the metadata from the document as a whole into each chunk to give the LLM additional context as to where this chunk came from, what the chunk is applicable to. This is important for things like, oh, this particular chunk came from this larger document. Here's a summary of the larger document. That way it can match more of these semantic searches. Additionally, this is where you would be able to specify tags that this chunk relates to, or products and product versions. This sort of information needs to be included in every single chunk. That way, when a similarity search is run, it has a better chance of coming up. Now, the final step in this pipeline is generating embeddings for our chunks. We need to choose an appropriate embedding model that can capture the semantic meaning of our content. If we're dealing with multilingual content, we might need special strategies, such as processing embeddings per language, or choosing optimized embedding models that are multilingual by default. The concept of vector embeddings is language agnostic. However, just like LLMs, embedding models have their own training data, and it's important that you choose an embedding model that is optimized for the language that you're trying to embed. Technical content also presents challenges, particularly with code snippets and with domain-specific terminology. If the terminology isn't included in the embedding model's training data, it might lose some of the meaning or intent behind the terminology as it tries to understand the words and translate them into vectors. The way we process our documentation has a significant impact on the performance of a RAG system. It affects the quality and the relevance of the context that we retrieve, which in turn influences the accuracy and usefulness of generated responses from LLMs. Poor document processing can lead to irrelevant retrievals and less helpful outputs. But that's vector-based RAG. I said that there were other flavors. And the other one is graph-based RAG. Graph-based RAG takes things a step further by incorporating structured knowledge in the form of a knowledge graph. This approach combines symbolic AI, the knowledge graph, with neural approaches, the LLM, and offers some unique advantages over purely vector-based RAG systems. Building a graph-based RAG system involves several components. We need to construct a knowledge graph that represents our domain knowledge. This often involves developing ontologies and taxonomies to structure the knowledge. We then need techniques to embed this graph structure so we can efficiently query it. Finally, we need to integrate this with our LLM. This diagram shows the flow of a graph-based RAG system. The user query is used to retrieve concepts and relations between concepts from the knowledge graph. This structured information is then provided to the LLM to generate a response. The knowledge graph itself is informed by the ontologies and taxonomies that define the structure of our domain knowledge. Graph-based RAG has its own set of advantages. It can explicitly represent relationships between concepts, allowing for more nuanced understanding between the concepts. It can handle more complex queries that require multi-hop reasoning. and it offers enhanced explainability because we can trace the path through the knowledge graph that led to a particular response and why that bit of context was passed to an LLM and why the LLM used that bit of context to create its output. But if you thought the advantages were good, so are the challenges. First, you have to create a knowledge graph. Constructing and maintaining a knowledge graph alone is complex and often requires significant domain expertise. There's also additional computational overhead in querying the graph structure, and it can be a great deal slower than a vector-based RAG. These factors can make graph-based RAG more challenging to implement and scale compared to vector-based approaches. And no, sorry, I'm not going to go into the practice of actually building a knowledge graph today. That's a whole other discussion. But knowing that there is a lot that goes on into this, there is a lot that is worthwhile in it as well. Another downside is that graph-based RAG might give relationships between concepts, but it doesn't actually retrieve the content from your documentation. It simply additionally informs the LLM of what the various concept relationships are. So a graph-based RAG dramatically helps an LLM in understanding what it's talking about. But a graph-based RAG alone does not provide it the content that the LLM needs to structure a good output. But now that we understand how these RAG systems work, and I apologize, I know I went over that quickly, let's discuss how we can optimize our documentation to work well with these systems. This involves thinking about how we structure our content, how we use metadata and tags, and how we reduce and how we balance the needs of human readers with the requirements of our RAG system. When structuring content for RAG, we think about how it can be chunked and retrieved. Clear, descriptive headings help both in chunking and in providing context. Logical organization makes it easier to preserve context when chunking. Summary paragraphs can be particularly useful as they often contain key information in a concise form. And consistent formatting across documents helps in processing and chunking. Metadata and tags play a crucial role in RAG systems because they can provide additional context that might not be captured in the main content. A hierarchical tagging system can help in organizing and retrieving information. Linking related content can help in providing additional context too. We also need to consider how we handle versioning in our metadata to make sure that we're retrieving the most relevant information at runtime. We need to balance the needs of human readers with the requirements of our RAG systems. This means writing clearly and concisely, which benefits both humans and machines. Where appropriate, we can use machine-readable formats like structured data. Maintaining a glossary of terms can help with consistency and can be incorporated into our knowledge graph for our graph-based RAG systems. Now, let's look at a real-world example of implementing RAG. At Skyflow, we hit a few roadblocks in managing our documentation and making it accessible through internal AI systems, but we overcame them and eventually excelled at creating a system that could leverage our RAG and uploaded documents to quickly draft new content. I'm not just talking about information retrieval, but using the retrieved information in novel ways. We built an internal system called Verba GPT to help us draft content quickly while still being accurate and knowledgeable about Skyflow. The heart of this system is a vector-based RAG that contains all Skyflow's public documentation, white papers, and blog posts. VerbaGPT includes a chat functionality that allows users to ask questions and receive AI generated responses. Users can also upload arbitrary documents, doesn't matter what, and VerbaGPT would use those documents to supplement the RAG results. But what struck gold was that the system could take RAG results and the uploaded documents, then apply them to templates based on doc type. So I could ask VerbaGPT to draft a new conceptual overview, and it would use the RAG results and any documents that I uploaded to create a first draft for me. Now, we definitely faced challenges in implementing RAG in VerbaGPT. We needed to integrate it with our existing documentation workflow without disrupting our processes. Our content updates frequently, so we needed a system that could handle this dynamically. Also, our content is highly technical and domain specific. We're a privacy and security company, which presented its own challenges. And we had to consider the arbitrary documents that users could upload. These could be anything from internal memos to customer feedback, and we needed to ensure that the system could handle this variable amount and type of content. Sometimes it could be huge, hundreds of pages. And so we developed several solutions. We created a custom chunking strategy that worked well with our technical content, preserving the context around code snippets and various technical terms. We built an automated pipeline for processing and updating our vector database, and we integrated this with our CI/CD pipeline to make sure that updates to our docs were reflected quickly in our vector database. To solve for the uploaded documents, we created an on the fly RAG setup with whatever was uploaded. We did the chunking, embedding, and querying whatever was uploaded at runtime, while also querying our main vector database. We also focused on locally hosted software components and privacy focused inference providers to hold to our ideals of privacy and data security. The impact of implementing our dual RAG strategy was significant. VerbaGPT was immediately aware of the uploaded documents and our documentation, able to cite its sources and to draft new content based on them. We were able to reduce the time to creating first drafts from time to releasing new documentation content from 2 weeks to 2 days. First drafts oftentimes went from 2 days to 5 minutes. The accuracy of our AI assisted responses improved dramatically thanks to the templates that we put together. Shout out, by the way, to the Good Docs project for providing awesome template bases. If you aren't using them today, you should go check them out. Our internal users benefited from enhanced search functionality that could understand the context of their queries, and it lowered the barrier of entry for docs contributions across the whole company. Whether someone was confident in their English or knew what structures and templates we used or not, everyone could now contribute with everything they had to offer. It was wins all around. Now, our next steps for VerbaGPT include exploring graph based RAG to leverage more structured knowledge. And we're also looking into agentic or tool based behavior, where the system can take more initiative in suggesting and drafting content based on conversations and user interactions. Additionally, once we have a graph based RAG, using the results of a graph query to inform multiple different vector RAG searches so that we have information both on what the initial user query, but also related topics that the LLM might leverage. As we look to the future, It's clear that RAG and related technologies will continue to evolve and will have significant impacts on our roles as technical communicators. It's important to consider both the opportunities and the challenges, including ethical considerations around AI generated content. Now, emerging trends in RAG tech include the hybrid approach that I just mentioned that combines vector and graph based methods, multimodal RAG that can work with text, images, and video, self updating knowledge bases that can autonomously incorporate new information, and the integration of agentic systems to enable not just information retrieval, but task completion, to allow LLM based agent systems to use the tools that they have at their disposal to query a graph or a vector database as often as they feel they need until they have the information to satisfy a request. As systems that incorporate RAG become more prevalent, the role of technical communicators will evolve, as it always has, and it always will. We'll likely see a shift toward content curation and quality assurance, ensuring that the information fed into RAG systems is accurate and up to date and high quality. There will be an increased focus on metadata and content structuring to optimize for AI consumption while still appealing to human readers. And we'll need to collaborate more with AI and ML teams, something that is still fairly rare today. And there will be a growing need for technical communicators to understand AI and ML concepts, at least in the ways that it affects our content and, well, our team's systems. And as we integrate AI more deeply into our work in these very specialized ways, we need to consider the ethical implications. We need to make sure the accuracy of AI generated content. We need to ensure the accuracy of our AI generated content and work to make sure it doesn't have any biases, or at least as few as we can reasonably manage. There's a need for transparency about when and how AI is used in content creation. And we also need to consider privacy concerns, especially when building knowledge bases from user generated content. We need to strike a balance, maintaining the human touch in our documentation even as we leverage AI technologies. RAG offers a powerful solution to the knowledge problems faced by LLMs. As technical communicators, we play a critical role in making RAG systems effective by creating well-structured and information-rich content. The future of documentation will likely involve a close collaboration between human expertise and AI assistance, opening up new possibilities for how we create and deliver information. RAG is a powerful technique that combines information retrieval with LLMs. Both vector-based and graph-based approaches have their strengths and use cases. The way we process and structure our documentation has a significant impact on RAG performance. As technical writers, we need to optimize our content for these systems. Just like print, web, and mobile, RAG is just another publishing service. It's a new way to get information out to our users, and we need to be experts in this new service, just like we are in the others. So please, experiment with RAG in your documentation workflows, experiment with AI and LLMs. Stay informed about developments in AI and machine learning as they relate to us. Advocate for the importance of well-structured content in your organizations. And engage in discussions about the ethical use of AI in documentation. Our expertise and perspective are vital to these as these technologies continue to evolve. Thank you all for your attention. If you're interested in hearing more, you can find me on LinkedIn or check out my projects, Doc Says Tests and Doc Detective. I'm always happy to chat about the intersection of technology and docs. See you around.
All right. Thank you, Manny, for that amazing talk. I was just saying that I learned so much because, LLMs, AI, it's one of those things that you know, as a concept, you might know the definition, but how to actually put it into practice is like a whole other system. So thank you for that.
My pleasure.
And you're not a robot. We're like seeing you here.
I'm definitely not a robot. I am here. I am verbose. I am emotive. All my kids are asleep right now, so I can do that.
Oh my God, we love to see it. All right, should we dive into your questions?
Let's do it.
All right, so the top voted question is, if your content has been updated, how do you teach your AI not to give outdated info?
So there are two things to discuss about this. First is that training an LLM is not the same as using a RAG system. So if you have documentation and you fine tune or train an LLM, that hard codes that information into the model. Retrieval augmented generation doesn't do that. It's just on the fly information retrieval. And so the model doesn't learn anything from it. You just stuff whatever information is pertinent into it, and then it goes. And then it forgets everything afterwards. As far as keeping content up to date, the way you do that is by making sure your vector database, if you're using a vector-based RAG, or your knowledge graph, if you're using a graph-based RAG, have that most up-to-date information. And you might do it in a very simple but computationally inefficient way. Like, cool, anytime there's a content update, rebuild the entire database, rebuild the entire knowledge
Makes sense,
graph.
yeah.
That's frankly what I'm still doing today internally with Verba GPT. But if you're taking this to external production, it might look something more like what MongoDB did with their system. I linked to MongoDB's Taking RAG to Production article in the chat during the talk. And that talks about how one of the things they've done is anytime there are doc updates, they update their vector database. It is still a database, so you can still update individual records. You just have to isolate, oh, hey, this page updated, let me re-chunk, re-embed this page and update that delta. But then everything's up to date, and the next time there's a retrieval, it fetches the updated information, so you don't have to worry about out-of-date content making it into your LLM.
Yeah, that makes a lot of sense, especially like, you know, a lot of these systems, it's like there's still like kind of like sometimes manual component of like ingesting things and making sure things are up to date. So great, thank you. And then for people who, you know, maybe are in my position where you're like, okay, this is exciting, this is interesting, but like I want to kind of like try it a little. I want to give it a little taste at work. In what situations or like what kind of content would you like maybe definitely recommend trying RAG, or maybe if you're just starting out, where would you just first implement it?
Fine. There are so many tutorials out there about chat over your docs. And first off, I'm going to say most of them are trash. But the idea, as far as like production usage, they have a lot of bad practices. But as far as learning how the concept works in theory, they're actually all pretty good starting points. So go to the LangChain docs, or go to the Llama Index docs, or whatever tool fits your comfort level with whatever language, programming language knowledge, if any, you have. Right now, it is still early days for these tools. And so if you want to get into the nuts and bolts of it, there is the learning curve of figuring out Python if you're going to use a lot of these. Some of them are available in JavaScript. But just go on to Medium, go on to dev.to, wherever else. There are so many of these tutorials that you can get your feet wet with, and then continue down the path of integrating with the tools that the tutorial starts with.
Would you recommend maybe starting, like if you want to start integrating this, maybe starting with like an internal documentation source to get familiar with the tool before you jump straight to like customers in production? Or
yes, absolutely. Do not jump straight to customers in production.
Just throw it at them. Easy.
Yeah. So here's the thing. You can use your external facing content, but only internally. So as long as it's on your machine, you can do whatever you want, with one exception. Wherever you are performing inference, so whoever's LLM you're using, you're going to have to send your content there. So
Mm-hmm.
if you can't, like if your company said, no, you can't use ChatGPT, well, guess what? You're likely not going to be able to use OpenAI's APIs either. So you have to choose wisely which inference provider you're using. But note that whereas most UI based LLMs like ChatGPT do take input data for training, their APIs don't. So OpenAI does not use any inputs or outputs from their API usage for training. And so that might make your security organizations reconsider what content can or cannot be used for specific applications.
Wait, I have a great follow-up to that. Which teams, if you're like, you're a technical writer or whatever role and you're wanting to start with this, what teams should you start with on your like organization? Should you be immediately talking to legal? Should you be talking to security? Who would you recommend getting involved in that conversation?
So I did a quick check with security, just be like, hey, this is what I'm planning to do. This is all public content already. So I'm not using anything that's sensitive, but I just wanted to give you all a heads up that this is something
Fair.
that's happening and give you the opportunity to say no. And they're like, no, you're fine. Go for it. It's all public. We don't care. If they would have a problem, they actually did bring up, no, do not use internal documentation. Do not use anything that is internal only. You can only use the public facing content. And I was like, cool, that's fine. I'm okay with that. But as far as who else to contact, if you're just doing this initial like POC, you don't need to contact anybody else. But when you get to the point of, oh, hey, these results are actually good, these results are something I want other people to see, then you're going to have to either get comfortable with whatever hosting infrastructure your company has, or go make friends with an engineer who is, because they're going to be the ones you need to talk to get it accessible externally. Now, I will state right now that everything I talked about, you don't have to build it yourself. You don't have to build it yourself. There are companies who are out there, and spoilers, I use one of them who I will not name right now because we're just talking in theory, but I use one of them for Doc Detective, and they take all of your docs and then they do all of the back end setting up the knowledge graphs or vector databases or whatever their systems are, and then they have the opportunity to chat over your docs. Now, please be careful if you look into these systems, because I've seen so many of them that are snake oil, but there are reputable ones that are out there. Just look for any tool. There is no best tool. Doesn't matter if it's this question or any others.
Oh my God, I was going to ask you if you had any thoughts on tools as a concept.
Yeah, well, I mean, I do have tools. I write a tool, not for this particular thing, but tools are wonderful in general. But just make sure that anytime you're evaluating a tool, but especially for late breaking technologies, look at their existing customer bases, see who they've integrated with, how they've integrated with them, because that will show you the sorts of things that you can expect. And many times, especially in the case of chatting over documentation, even let you see how they respond and if that's something you want for your docs.
That's great. I think that's the perfect note to end on. So thank you so much. If people have other questions, where can they find you?
Please find me on LinkedIn. I like to think I'm very friendly. But
I can.
I'm also on the Write the Doc Slack pretty much every day. So feel free to hit me up wherever you're most comfortable.